We're very quickly going to show how geometry nodes could be used to create the distributed stones on the Martian landscape. So the first thing to do is to switch to active workspace for geometry nodes, delete the start cube, add a plane, and then we add a modifier, geometry node modifier. Straight off we add a primitive icosphere and drop it onto the connecting line between the group input, which was a plane, and the output. And then we'll try modifying the location of the vertices by using a set position node. And you see we can feed a random value into the offset. If we subdivide the icosphere before setting the positions, we end up with a more random distribution with lots of potentially overlapping points. So it's better to do the random moves and then subdivide afterwards. We also want to be able to change the proportions of our rock, make it flatter or make it longer in one direction. So we add a transform node so we can see the problem with the subdividing before the randomizing. And finally, we can set some of the nodes, some of the vertices, to shade smooth. You see, in this instance, we're going to pretend that the underside of the rock has eroded smoothly because of the heating and cooling on Mars, but the top has remained faceted. So we do that by looking at the direction of the normal of the vertices. They're above horizontal, we'll make it flat, and where it's below, it's neutral. So we make our nodes into a group, which we'll call the rock generator. And we're going to have a random seed so we can vary them, and we're going to make it so we can change the scale of each of them. In order to scatter our rocks, we're going to put a node to distribute points to faces onto the plane, and now we need to feed instances of our rock onto the randomly distributed points. So the first thing to do is to change the scales of the rocks to something that's going to match. But we see that quite a lot of them are overlapping each other, and we can fix that by changing to the Poisson disk rather than the random distribution. And then we can adjust the minimum distance and the density maximum. And the density factor, you'll see, we will control later by getting a texture input. We need to join the geometry of the plane to the geometry of the distributed instances of rocks. We need to move the rocks upwards rather than having so we can do that by changing the scaling, so the band of minimum and maximum scaling. We duplicate our group, and then we'll change the scales and seed values for each of our types of rocks, so we get a variety, and we convert the different instances using a geometry to instance node. Now you notice that we're going to have to do something to rotate the rocks randomly because they're all pointing the same way. Notice if we scale the plane, it doesn't increase the density. We need to go into edit mode and increase its actual size. And we need to make the rocks rotate with the normal. So we actually feed the rotation from the distribution points on faces into the instances. And to get a random value to rotate them about a vertical axis, we can generate a float random value for the rotation amount, and then have an Euler rotation in addition to that about the vertical axis.